Hey everybody, MDP here. Welcome to our deep dive into the world of robotics. Get ready to have your minds blown, because we're about to explore some of the most groundbreaking advancements and future frontiers in this exciting field. From robots that can dance better than your uncle at a wedding to ones that can perform surgery with incredible precision, we're covering it all. So buckle up, smash that like button, and let's get this robot party started. All right, guys, let's kick things off with the robots we all dreamt of as kids, humanoid robots. We're getting closer to that reality every day. Companies like Tesla and Boston Dynamics are building robots that can walk, talk, and even learn. Take Tesla's Optimus, for example. This robot is designed to handle everyday tasks. Imagine a future with your own personal robot assistant. And then there's Boston Dynamics Atlas, a parkour expert in robot form. It can jump, flip, and do backflips, all while maintaining perfect balance. It's incredible to watch and shows just how far humanoid robots have come. These robots are becoming incredibly intelligent thanks to AI. They can navigate complex environments and learn new tasks quickly, opening up a world of possibilities from healthcare to disaster response. Next up, we're talking about robots that are here to make our jobs easier and safer. Collaborative robots, or cobots for short. These robots are designed to work alongside humans, not replace them. Think of them like your super helpful co-workers who are always willing to lend a hand, or a robotic arm, as it may be. Companies like Universal Robots are leading the charge in this field, creating cobots for a wide range of industries. In manufacturing, cobots can handle repetitive tasks like welding or assembly, freeing up human workers to focus on more complex and creative aspects of the job. And because they're designed with safety in mind, cobots can work in close proximity to humans without posing a risk. Cobots are also being used in healthcare, logistics, and research labs to automate experiments. The best part? Cobots are becoming increasingly affordable and user-friendly, making robotics more accessible than ever before. Okay, get ready to be amazed, because now we're diving into the world of swarm robotics. Imagine a team of tiny robots working together like a colony of ants or a swarm of bees. That's swarm robotics in a nutshell. One of the coolest examples is Harvard's RoboBee project. These tiny flying robots are about the size of a penny and can fly, land on water, and even swim. The idea is to use swarms of RoboBees for things like pollination, search and rescue missions, or even environmental monitoring. Then there's Festo's bionic NTs. These robots are modeled after real ants and can communicate and cooperate with each other to complete tasks. They can even share energy wirelessly, just like their insect counterparts. The beauty of swarm robotics is that it's incredibly scalable and decentralized. This makes swarm robotics ideal for tackling complex problems in challenging environments, from exploring disaster zones to mapping out underwater ecosystems. Now, let's talk about robots that are anything but rigid and clunky. Get ready for the world of soft robotics, where robots are made from flexible, squishy materials. One of the pioneers in this field is Harvard's Octobot, a completely soft, autonomous robot inspired by octopuses. It's made entirely of silicone rubber and powered by a chemical reaction, allowing it to move and change shape without any rigid components. Soft robotics is revolutionizing how we interact with delicate objects and environments. Imagine robots that can gently handle fruits and vegetables in agriculture, assist with delicate surgeries in medicine, or even provide safe and comfortable assistance in rehabilitation. The future of soft robotics is bright, and we're only just beginning to scratch the surface of its potential. Buckle up, because we're about to take a ride into the future of transportation with autonomous vehicles and drones. Self-driving cars, delivery drones, and autonomous robots are no longer science fiction. They're here, and they're changing the game. Companies like Waymo, Tesla, and Cruise are leading the charge, with self-driving cars being tested and deployed in cities worldwide. Imagine a future where traffic jams are a memory and car accidents are drastically reduced. That's the promise of autonomous vehicles. And then there are drones. From delivering packages to inspecting bridges, drones are changing how we do business. Companies like Amazon and Google are investing heavily in drone technology. Autonomous vehicles and drones have the potential to revolutionize industries like agriculture, construction, and filmmaking. Next up, we're talking about robots that are changing lives by restoring mobility and enhancing human capabilities. Prosthetics and wearable robotics. These incredible devices are helping people regain their independence and achieve things they never thought possible. Companies like Open Bionics are creating affordable and highly functional prosthetic limbs using three-dimensional printing technology. Their Hero Arm, for example, is a customizable and intuitive prosthetic arm designed for children. It's lightweight, easy to use, and even comes in different colors and designs. And then there are exoskeletons, wearable robotic suits that can boost strength, endurance, and mobility. Exobionics, for example, develops exoskeletons for people with spinal cord injuries, allowing them to stand, walk, and even climb stairs. Wearable robotics can also enhance human capabilities in industrial settings, helping workers lift heavy objects, reduce fatigue, and prevent injuries. The future of prosthetics and wearable robotics is incredibly exciting, with researchers constantly pushing the boundaries of what's possible. Hold on to your hats, folks, because now we're entering the realm of science fiction turned reality brain-machine interface robotics, or BMI for short. This is where things get really wild because we're talking about controlling robots with the power of our minds. Companies like Neuralink, founded by Elon Musk, are developing implantable brain-computer interfaces that could revolutionize how we interact with technology. Imagine a world where you can control a prosthetic limb, a computer, or even a robot simply by thinking about it. The implications for people with paralysis or neurological disorders are immense, but the potential applications go far beyond that. BMI robotics could revolutionize gaming, communication, and even art, allowing us to express ourselves and interact with the world in entirely new ways. Of course, with any revolutionary technology, there are ethical and safety considerations to address. Get ready for a mind-bending concept: self-replicating and self-healing robots. Imagine robots that can repair themselves, adapt to changing environments, and even create copies of themselves using available resources. It sounds like something out of a science fiction novel, but researchers are making incredible strides in this field. One of the key areas of research is in self-healing materials. Scientists are developing materials that can repair themselves when damaged, just like our own skin. Imagine robots that can recover from minor injuries or wear and tear without the need for human intervention. And then there's the even more mind-blowing concept of self-replicating robots. While still in its early stages, this technology has the potential to revolutionize space exploration, hazardous waste cleanup, and even large-scale construction projects. Imagine sending a team of self-replicating robots to Mars to build a base camp before humans arrive. Now, let's talk about the holy grail of robotics, human-like general intelligence in robots, or AGI for short. This is the stuff of science fiction dreams and philosophical debates, but it's also a field that's rapidly advancing. AGI refers to artificial intelligence that can understand, learn, and perform any intellectual task that a human being can. It's about creating robots that can reason, solve problems, and adapt to new situations just like we do. The potential benefits of AGI are enormous, from revolutionizing healthcare and education to solving complex global challenges like climate change. Imagine robots that can work alongside scientists to develop new medicines, or robots that can provide personalized education to students of all ages. But AGI also raises profound ethical and philosophical questions. Finally, let's explore the fascinating world of bio-inspired robotics, where engineers and scientists are turning to nature for inspiration in robot design. By mimicking the incredible adaptations of animals and plants, researchers are creating robots that can move, sense, and interact with the world in entirely new ways. Take, for example, the field of microbots. Inspired by bacteria and other microorganisms, scientists are developing tiny robots that can navigate through complex environments like the human bloodstream. These microbots could revolutionize targeted drug delivery, minimally invasive surgery, and even disease diagnosis. And then there are robots inspired by animals like cheetahs, snakes, and birds. Bio-inspired robotics is all about learning from nature's best designs and applying those principles to create robots that are more efficient, adaptable, and resilient. Wow, we've covered a lot of ground today. From humanoid robots to swarm robotics and everything in between, it's clear that the future of robotics is incredibly promising. As technology continues to advance at an unprecedented pace, it's more important than ever to stay curious, stay informed, and engage in thoughtful conversations about the role of robotics in our lives. Thanks for joining me on this incredible journey into the world of revolutionary robotics.